Hello everyone, welcome to my channel btech basics. Today I am discussing about test state and also theorem about equivalence of DFA and NFA. Now we see what is test state. Test state is a state when where the control can enter and be confined till the input ended, but there is no way to come out from the state. So, test state is used in automata to trap invalid inputs and ensure they do not get accepted. Once they entered, the machine cannot escape from it no matter what input follows. So here one finite automata is there. Here they given three states Q0, Q1, Q2. So here Q0 with input 0 goes to Q1 and there is no input 1 for Q0, and Q1 with input 0 remains in the same state and Q1 with input 1 goes to Q2 state and Q2 with input 1 goes to Q0 state. From the above diagram, Q0 for input 0, there is a path to go to Q1. So here in this diagram there is Q0 for with input 0, there is a path to Q1, but there is no path mentioned from Q0 for input 1. So there is no path from Q0 with input 1. The same thing happen also for Q2 for input 0. So the same thing happen above we mentioned. So here there is no Q2 with input 0 for Q0. Now let a string 101 be given as input to the finite automata to test the acceptability of the string by the finite automata. So here we have to include an extra state, say QF. So here we include an extra state, that is QF, where the control will go from the states for which there is only one path for one input. So where the control will go to the states, will go from the states for which there is no only one path for one input. In the QF state, for the inputs there will be self loop. So in QF state inputs ki self loop anedi undi. Here QF is a test state. So in this diagram QF is a test state. So what I said, what is test state? Test state is used in automata to trap invalid inputs and ensure they do not get accepted. Once entered, the machine cannot escape from it no matter what input follows. So here QF is test state, and by including the test state the finite automata becomes as shown in figure. So in this figure we connect to input 1 and input 0 to QF from the Q0 and Q2. So test state makes the string totally traversed. So test state anedi string ni total ga traverse chestundi. Okay, this is about test state. So test state is a state where the control can enter and be confined till the input ended, but there is no way to come out from the state, and also the machine cannot escape from it. So next topic is, so this is very important theorem, equivalence of DFA and NFA. So here what is statement? If a language L is accepted by an NDFA. So here NDFA is non-deterministic finite automata. Next, then there is exist a DFA that accepts language. So here DFA and deterministic finite automata. So what is statement? If a language is accepted by an NDFA, then there exists a DFA that accepts language. So now we see proof. Let M be an NDFA denoted by set of Q sigma delta Q naught F which accepts language. So ikkada manam NFA ni M తో డినోట్ చేస్తున్నాం. సో MB and M అనేది ఇక్కడ NFA. సో వీఆర్ డినోటెడ్ విత్ ఫైనైట్ సెట్ ఆఫ్ స్టేట్స్ అండ్ సిగ్మా అంటే ఫైనల్ సెట్ ఆఫ్ ఇన్పుట్ సింబల్స్, transactional functions, initial state and final state which accepts language. Next we construct a DFA M dash set of Q dash sigma delta dash Q naught dash F dash where Q dash contains the subset of Q, that is Q dash equal to 2 power 0. సో ఇక్కడ మనం DFAని M dash తో డినోట్ చేస్తున్నాం which include a set of Q dash, same finite set of states, finite set of input symbols, transactional functions, initial state, final state where states contain the subset of NFA in M. So Q, that is where Q dash equal to 2 power 0. Now here Q dash may be denoted by Q1, Q2 and so on Q1 as a single state where Q1, Q2 and so on Q1 belongs to Q. So here Q dash అనేది Q1, Q2 and so on Q1 తో డినోట్ చేస్తాం as సింగిల్ స్టేట్గా where Q1, Q2 belongs to Q state in NFA. Next initial state. Initial state Q naught dash equal to Q naught or set of Q naught. So here initial state ante Q naught dash equal to Q naught or set of Q naught and final state F dash equal to set of all states in Q dash containing at least one final state of M. So set of what here, what final state? Set of all states in Q naught Q dash in DFA containing at least one state of M. So NFA లో at least one state contain అయి ఉండాలి. Next transitional functions are defined as DFA delta dash of Q1, Q2 and so on Q1 comma A means with input A equal to P1, P2 and so on Pn where Q1, Q2, Q1 are belongs to Q and A belongs to input symbol sigma. So in this transactional function Q1, Q2 and so on Q1 with input A gives to P1, P2, Pn where Q1, Q2 belongs to Q and A belongs to input symbol. Next here transactional function of Q1, Q2, Q1 with input A gives to delta of Q1 with input A union delta of Q2 with input A union and so on union delta of Q1 with input A. So equal to P1 union, P2 union and so on Pn. So here this is the case for a single input A. We prove it for some input string X. So here X may be length 0 to length n. In this case this is case for single input A. So here we are taking only single input A and we prove it for some input strings. So we have to prove it for some input string X. Here X may be length 0 or length 0 to length n. We prove this by induction. So here there are two conditions, one is base condition and another one is induction condition. So here first we see base condition. Let mod x equal to 0. So here I am taking let mod x equal to 0. Here x is a null string and delta dash of Q naught dash with input x equal to Q naught as Q naught dash equal to Q naught. And so this is DFA and this is NFA. We are represented with dash in DFA. So here delta dash of q naught dash with input x gives q naught, so it is remains in the same state, and delta of q naught with input x equal to delta of q naught with null string equal to remains in the same state, that is q naught. In induction condition, let us assume that that is a true for each string of length n. So we have to assume that it is true for each string of length n, and now we need to prove that the result is true for any string of length n plus 1. So we need to prove what the result is true for any string of length is n plus 1. So here we have to assume each string of length n, and we need to prove that the result is true for any string of length n plus 1. We have to take s equal to xa. So we are assume that s equal to xa. So in DFA, mod s equal to mod xa. So here we can write it as mod x plus mod a equal to n plus 1 form. So here we are writing DFA what mod s equal to mod xa and equal to mod x plus mod a, we can write it in n plus 1 form. In NFA, delta dash of q naught dash comma s equal to in s place we have to substitute s value. What is s value? xa. So delta dash of q naught dash comma xa equal to delta dash of q naught dash comma x comma a. So by induction it is proved that n length string is delta dash of q naught dash with input x gives p1, p2 and so on pk if and only if delta of q naught with input x gives p1, p2 and so on pk. So n plus 1 length string is proved by induction step. So n plus 1 length string is proved through induction step. So in DFA, delta dash of q naught dash comma with input x again comma with input a gives to delta dash of దీన్ని మనం ఏం రాయొచ్చు, q naught dash comma x, దీన్ని ఏం రాయొచ్చు మనం p1, p2 and so on pk గా రాసుకోవచ్చు. with input a gives r1, r2 and so on rk in DFA. Next in NFA, delta of p1, p2 and so on pn with input a gives delta of p1 with input a union delta of p2 with input a and so on gives r1 union, r2 union and so on rn. Thus delta dash of q naught dash comma xa equal to delta dash of q naught dash comma a with input a gives r1, r2 and so on rk. So it is proved that the result is true for a string of length n plus 1. So it is proved that the result is true for length n plus 1 string. If it is true for a string of length n, now delta dash of q naught dash with input x belongs to final state in DFA. When delta of q naught with input x, it is belongs to final state in NFA. So it is proved that language of m equal to language of m dash, where language of m is NFA and language of m dash is DFA. So NFA అయితే we are denoted with m and DFA అయితే we are denoted with m dash. So we have to prove in two conditions, base condition and induction condition. We have to prove in this way. So in another video I will discuss about finite automata with output. In that topic there is two missions are there, melee mission and more mission. So in another video we will see that topic. So I think everyone would understand my class. Thank you for watching. Please do share, like and subscribe.